Okay, good morning, everybody. May 13th, huh? So here we are, you guys. We really have a month to go. We can do this. We can. So first of all, some of you have not finished Chapter 8. Please get Chapter 8 into me. If you need a copy of Chapter 8, ask. I have a really nice video, 8 for Algebra, Test 8. So you just have to find that on YouTube. It'll walk you through the test. So I have to just watch the video and take the test at the same time, okay? All right. Correct homework. Let's take a look at today's homework. Today's homework is over here. Okay, number 1, I set them equal and I got x equals 5. Number 2, I set them equal and I got x equals 35. Number 3, yes, those are parallel by corresponding angle theorem. So again, I keep talking about these things like the F. So hopefully you can see that these two lines make the F. Those are corresponding angles. Number 2, nope, we don't know anything between these two lines, so those are vertical angles, but we don't know they're parallel. Same thing here, these are vertical angles, so it just tells us we don't know. It's not enough information, okay, between these two. And number 3, yes, these are going to be exterior, so they're alternate exterior angle theorem, so yes, that is going to be parallel, okay? Now, today's lesson, let's see, if we were in class, I wish we were, I would teach you how to do this, but unfortunately, you're not in class, so I'm going to have to teach this to you. So this is called a construction. Now, back in the old days, a long time ago, before there was computers and all sorts of fancy things, people used to use compasses and rulers to do things. Crazy, huh? So let's look at this. The word perpendicular means 90 degrees, like that, well, like that, and bisector means to cut it in half. So what I want to do is find a perpendicular bisector. So the way you do that, so I'm going to do it by construction. I'm going to use a compass, and I wish we were in class because I'd have you do this. So my compass now, I'm going to spread it out so at least it's got to be bigger than halfway. So I'm going to make my compass almost 2/3 the size of my line, okay? Alright, so it doesn't have to be perfect, but it's got to be more than half, okay? Take my pokey part. See my pokey part? I'm going to put it on A. So put it on A, point A, and I'm going to go, are you watching? I'm going to go swoop, I'm going to do an arc here and an arc down below. Oop, darn it. Okay, hopefully you can see that. And then, don't change the compass length. Bring it over here. Put on B. Do a swoop here, and a swoop here. Now what we get, if we do our little arcs, is we get 2 points of intersection. Let's call that point P and point Q, okay? And if I draw a line from P to Q, which I will, I'll do that right now, I get a line. So line PQ is the perpendicular bisector. Well, here, what does that mean? Okay, it crosses at 90 degrees. It really does. And bisector, it cuts it in half. So let's call this M, point M for the middle, like midpoint. And then I know that this side, AM, is congruent to this side, MB, okay? AM is congruent to MB, okay? That's perpendicular bisector, and that's how we construct it. Again, we use our compass, we go whoosh, 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 pokey here, whoosh, 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 we get 2 points, draw the line, and it's a perpendicular bisector, 90 degrees, cuts it in half, bisector, okay? Now, example 2, we're going to do the same kind of thing. So the distance from P down to the line, let me think about this. You guys are smart. So if I were to draw my line, and if I were to draw it like the true distance, I wouldn't measure it there. I wouldn't measure it there. I'd measure it straight up and down, right? The shortest distance, straight up and down. So the measuring, it's not going to, nobody would measure it at an angle. That's silly. So we measure it straight up and down, okay? To get it straight up and down, it's got to be perpendicular, okay? Okay, so we're going to do this using a construction again. So I'm going to do the exact same construction I did up above, except for I need these 2 points. I need these 2 points, A, B, but I need these 2 points down here. Okay, so I take my compass. I'm going to create A, B. Now, so I'm going to take my pokey. Call it pokey. I know it seems kind of silly. And what I'm going to do is I'm going to just draw a line. There's 1 point. Let's see if you guys can see that better. Okay, and I'm going to come over here and go. And what I've done is I've created my points A and B from up here. So now I have a line segment AB. A is there. B is there. Okay. Now I want to do the exact same construction I just did up above. Okay. So then take my pokey on A. Okay. I'm going to go and I'm going to go. Okay. Take from B. Same thing I did up above. Okay. Now I've created point Q below. I've got point P, point Q, and then I draw in my perpendicular bisector. Okay. Now, what we know, this is a midpoint, M. What I know is this distance, PM, is the shortest distance to line A, B. Okay, right there, that's the distance. Now you can measure it with a ruler, sure. Maybe, looks like maybe 5/8 of an inch, possibly, or in centimeters. Looks like it's about maybe 1.8. Either way, this is about constructions. And when you look at the journal, you'll see they'll walk you through the constructions. Okay, now, third example. Okay, all right, here's what I have. Here's P. Here's my line L. And I want the distance. So I want to find the actual distance from P to the line. Okay? So we're going to do the exact same type of construction, except when you look at the homework today, they haven't actually done a construction. What they've done is they took line P and they actually drew some things for you. So the first thing they drew, if you see this point here, that's the midpoint. So I've got a triangle that the book is going to draw for us. Now I know if I use my compass, right, I can show that these 2 points are equal distance. Okay, show that. Okay, hold on. There's my there. Okay, so there we go. And what I'm going to do then is create a triangle out of this. So let me draw my triangle. Draw my triangle. Draw my triangle, okay. And I want the distance from P to line L, then it's got to be perpendicular, okay. It has to be perpendicular, okay. So, it's got to have this opposite slope. So this line has a slope, line L has a slope. Remember, a slope is rise over run. And it's going to be up 3 over 1, up 3 over 1. So from point P, it's going to be the opposite slope. So rise, run, up 3 over 1, up 3. So it's going to have the opposite slope instead of up 3 over 1. This one's got to have a slope of down 1 over 3 to be perpendicular. So sure enough, this is how they get this point. You're going to go down 1 over 3, down 1 over 3, and there it is right there. Okay, so now this is perpendicular. So that's got to be the distance, the shortest distance, right? So let's label this point. Let's call this point Q, all right? So what I want to find is the length of PQ. So I want to find the length of PQ, all right? So to find the length of PQ, what I need to do is, well, I could use the distance formula, or I could use Pythagoras Theorem, okay? So the distance formula we've learned before. So point P is the point at 3, negative 3. Oops, negative 3, 3, my bad. Negative 3, 3, and point Q is at the point 3, 1. And the distance formula, d is equal to the big square root, remember this? x2 minus x1 squared plus y2 minus y1 squared. Okay, so how does distance formula work? We've done it before. x1, y1, x2, y2. We've got 2 points, right? So my distance is going to equal big square root of x2, which is 3, minus x1, which is a negative 3, double negative, squared, plus y2, which is a 1, minus y2, which is a 3, squared, okay? Distance is equal to double negative, remember? See the double negative? Plus, plus, get a plus. Plus, we get a 6 squared, plus a negative 2 squared. Don't forget, negative 2 squared is a positive 4. Distance equals square root of 36 plus 4. Don't mess this up. Negative 2 squared is a positive 4. Distance equals the square root of 40. And what's the square root of 40? I don't know, that's my calculus 4, okay? Square root of 40. And I get an answer of about 6.32. Now in geometry, we're going to do this slightly different. So when you guys get to geometry, we're just going to create a right triangle. And you guys can see if I create a right triangle. See my right triangle right in here? Geometry will create a right triangle because we know about Pythagoras Theorem. You do. You guys have learned about Pythagoras Theorem. A squared plus b squared equals c squared. So really it's the same thing. It is the distance formula. So I've got a squared plus b squared equals c squared, c squared. This length is what I want. So I could, instead of using the distance formula, which works, I can use Pythagoras Theorem. I created a right triangle. I'm going to go, okay, that's 2, 1, 2, 3, 4, 5, 6. Hey, what do you know? There they are. Okay, so I'm going to go 2 squared plus 6 squared equals c squared, right? 4 plus 36 equals c squared. I like this way, it's much easier. It only works on graph paper though, okay? 40 equals c squared. To solve for c, I'm going to square root. Square root of 40 is going to be, well, what do you know? We just did it. 6.324. 6.32. Okay, either way, I think making a right triangle using Pythagoras Theorem is easier, but we can also use the point, okay? So I got a point. One time I got a point here at negative 3, 3. I had a point here at 3, 1. Okay. All right, that's quite a bit today, but I have faith you can do it. So homework. Let's take a look real quickly at homework today. And where did I put my notebook? Here's my notebook. Okay. Homework is going to be page 294, 1 through 8. Let's look at that. 294. 294. Let's look at that. 294. Here it is. Okay. So, number 1, find the distance. So they draw the triangle for you. You just have to find this length. Okay. Either Pythagoras Theorem or by using the distance formula. Okay. Same thing. Either by Pythagoras Theorem or the distance formula. Same thing, here's the distance, either by Pythagoras Theorem or distance formula, same thing, find the length, okay? You can do that. And then on this, why are they parallel? Are they parallel? Well, I don't think so because we don't know anything over here, okay? This one, yes, I'd say they're parallel because those are corresponding angles. Are they parallel? Yes, because if that's 90, that's 90, I'd say yes. On 8, probably yes, because if that's 90, that's got to be 90 there because those angles are equal. That makes 90, so I'd say yes, okay? Anyway, there's your homework. Get that Chapter 8 test done. Get your homework to me, and I'll talk to you tomorrow. All right.